In this video we talk about liquid chromatography. Before we start, please support us by like and subscribe. Please support us, like and subscribe. Let's begin. Liquid chromatography, LC, is a technique used to separate a mixture of substances, analytes, in a liquid solution or suspension. It is a valuable method for the quantitative and qualitative analysis of complex, often biological, samples. The separation is based on the differential partitioning between the mobile and stationary phases. The basic principle behind chromatography is that different substances will have different affinities for a mobile phase and a stationary phase. In liquid chromatography, a solution, the mobile phase, is passed through a column that contains a solid or liquid stationary phase. The different components in the solution interact differently with the stationary phase and, therefore, move at different speeds. This causes them to separate from each other. Types of liquid chromatography include high-performance liquid chromatography, HPLC. This is a type of liquid chromatography used to separate ions and molecules in a solution so they can be identified and quantified. HPLC is considered a high-resolution, rapid and sensitive technique for differentiating and identifying complex mixtures of substances. Reverse phase liquid chromatography, RPLC. This is a type of liquid chromatography where the mobile phase is significantly more polar than the stationary phase. Size exclusion chromatography, SEC. This is also known as gel permeation chromatography or gel filtration chromatography. It separates molecules according to their size, or more accurately, their hydrodynamic volume, rather than their chemical composition. Ion exchange chromatography, IEX. This type of chromatography separates ions and polar molecules based on their affinity to the ion exchanger. Normal phase chromatography, NPC. In this type of chromatography, the stationary phase is polar and the mobile phase is nonpolar. Affinity chromatography. This type of chromatography separates biomolecules based on a highly specific biologic interaction, such as that between antigen and antibody, enzyme and substrate, or receptor and ligand. Each type has its own specific applications, but all share the underlying principles of liquid chromatography. The method is widely used in various industries, including pharmaceutical, biotechnology, environmental, and food and beverage.